Let's determine the empirical and molecular formula from mass percent. A sample is analyzed and found to contain 43.64% phosphorus and 56.36% oxygen by mass. The compound has a molar mass of 283.88 grams per mole. What are the compound's empirical and molecular formulas? Let's find the empirical formula first. When dealing with mass percent, it's easiest to assume a 100-gram sample, because it is convenient to convert percentage to masses. Then we can convert to find moles of elements, then ratios. Based on percentages, a 100-gram sample will have 43.64 grams of phosphorus and 56.36 grams of oxygen. We can find the moles of each element next. This mole ratio isn't the simplest whole number ratio, so we can divide each mole by the smaller value. Notice that dividing by the smallest moles results in a fraction for oxygen. This isn't the simplest whole number ratio either. When a fraction occurs at this point, we can multiply all the moles by a whole number in order to obtain a whole number ratio. In this case, 1 mole of phosphorus and 2.5 moles of oxygen can be multiplied by 2 to give an empirical formula of P2O5. We can now find the molecular formula by finding the relationship between the molecular formula mass and the empirical formula mass. I have earlier videos describing this equation. The empirical formula is 141.94 grams per mole, while the molecular formula, 283.88 grams per mole, was given in the problem. This gives us a ratio of 2. We can distribute the ratio of 2 to find the molecular formula of P4O10, or tetraphosphorus decaoxide.